All right, welcome back to 8.7. We are looking at word problems of sinusoidal functions today. So ultimately, when we create these or using these math functions, really what we wanted to do is to try to model the real situations, right? So that's what math is used for, right? We use it in real life uh, to kind of model the situation so we can actually solve the problems. Okay, so we're going to be looking at several different kinds. Okay, so let's look at the warm-up question first. It says when the last person gets on a Ferris wheel, it begins to rotate. This graph shows the height above the ground of that person as a function of time. Okay, here's the graph. That's the height of a person on the Ferris wheel. First question says, how high above the ground does a person get on the Ferris wheel? Well, how high above the ground? Well, I guess that's when the time is 0, right? So what's the height of this person? Or how high above the ground is this person when time is 0? Because that's when he gets on. Well, it looks like this is where, or this is when it gets on, when time is 0. And the height, it looks like 5 feet to me, right? Because 2 boxes is 10, which means 1 box is 5. So 5 feet. What is the radius of the Ferris wheel? Well, the radius, I mean, if you think about this, I'm just going to quickly draw a Ferris wheel. Looks something like this, I suppose. So if this person gets on here and it begins to rotate, it's going to go up to the highest point right there. So this will be the lowest point, and that will be the highest point. We can find the diameter simply by subtracting the maximum with the minimum. So you can see the maximum here is 45. Okay, and the minimum here is 5. So the diameter is going to be from 5 to 45. So we know the diameter is going to be 40, right? Diameter is going to be 45 minus 5, which is 40. Therefore, radius is going to be half of that, which is going to be 20 feet. Okay, so that's the radius of this Ferris wheel. Part C says, what is the time for one revolution of the wheel? Well, you can see it starts from the lowest point. It's going to go up to the highest, and go down to the lowest. So go down to the lowest. So this will complete one full rotation. So this is 2 minutes. Okay, so you can see this, the height of a person on the Ferris wheel. Actually, we can use sinusoidal function to model the situation because it just keeps going. I mean, it just goes up, comes back down. If this Ferris wheel keeps going, right, keeps on going, just keep rotating, it's just gonna keep go up and down, and so on. Okay, with the same height, right? It goes to the same maximum, goes back down to the minimum, and keeps going forever. Well, it doesn't go on forever, I hope, but it does. It could go on forever, I suppose. Okay, so we are gonna do something like this for this lesson. Okay, but we are gonna come up with a graph ourselves. Okay, this one gives that to us. That's okay. It's a warm-up question. So, but we can see it follows this pattern, sinusoidal function. Right? Again, sinusoidal function simply means the graph looks like a sine wave. Okay, so let's look at the first one here. It says the first Ferris wheel was built in 1893. The diameter of the wheel was approximately 76 meters, and the maximum height was about 80 meters. The wheel completes one full rotation in 3 minutes. Okay, so part A says determine a function that models the height h meters of a cart at any time t minutes after the wheel begins to rotate, assuming you get on the cart with the lowest height above the ground. Okay, so I think doing a sketch really helps. Okay, so that's what I'm going to do right away. Okay, so I know I get on the lowest point of the Ferris wheel. I know that it's going to go up and then come back down like this. Okay, I'm just going to draw one cycle. It says one full rotation is 3 minutes. So I know when I come back down here, this is going to take 3 minutes. Okay. It says the diameter is about 76 and the maximum is 80. So here is going to be 80 meters above ground. Now, because the diameter is 76, that means the minimum is going to be 4 meters above ground. Okay, so then you can see the diameter. This wheel is going to be 76 meters long, I guess, for the diameter. Okay, I guess that's all, right? That's all the information that's given to us. We can actually create an equation for this, okay? So what I'm going to do now is I'm going to write down all the information that I have, okay? Now, part A says determine a function. So for the first question, I'll actually show you both sine function and cosine function because we can actually do both, okay? So sine and cosine. We can actually do both. Now, okay, so if we write it as a sine function, okay, that means we start at the middle, right? Recall the sine function starts at origin, right? So here, if we put a point here, that's the middle between 4 and 780. This is where it starts. Okay, now first of all, I'm going to figure out where the center line is because this is the center line. I need to find out where that is. Okay, now we're looking at the midpoint, right? So basically to find midpoint, so center line is simply the vertical displacement. To find the middle, we simply take the average of the two, right? Take the average of the minimum and the maximum. So vertical displacement is going to be 80 plus 4 divided by 2. This is going to be 42, so that's where the middle is. We can then find the amplitude because we now know the vertical displacement. Amplitude is simply the maximum minus the center line, so 80 minus 42, which is 38. That's my amplitude. We can then find the period. We know the period is 3 minutes, which means B is going to be 2 pi over 3. Okay. Period is 2 pi over B. B is same thing as 2 pi over P. Okay. So again, you can manipulate. I believe this is one I show you, but if you manipulate for B, you get B equals to 2 pi over P. Finally, we can find the phase shift. Phase shift is simply how far away, because this is basically our new sine starting point, right? Starting point for the sine, because that's where it starts, the middle, and it goes up. Okay, now because if you think about this, if you continue to go, you're gonna, oh, it doesn't go lower anymore. It's gonna go up like that. So that'll be one full cycle, and this will be 3 minutes. If you look at one full cycle, you can actually break this into 4 parts, right? Maybe I don't need this part. You know what? I'm not gonna do that. Okay, so this is gonna break into 4 parts. Here and here and here. Okay, so that's first quarter, second quarter, third quarter, and fourth quarter. Right? So you see, one full rotation is broken into 4 parts. That's the first part, second part, third, and fourth. They are equidistant. Okay, so that means from 0 to 3, it's going to break into 4 pieces. That means this is going to be 3/4 of a minute. So the phase shift is 3 over 4. Okay, because again, the whole thing is 3, but we are breaking into 4 parts or 4/4. So 3 divided by 4 is 1 piece. Okay, so that's all we have, and that's all we need. Okay, so now we can write the function. It's h of t, the height in terms of time, is going to equal to amplitude is 38. Sine b, the value of b was 2 pi over 3, times x, but we have time this time around, so t minus the phase shift, which is 3/4, plus the vertical displacement of 42. Okay, so that's your sine equation. And you can do something similar for the cosine equation. Everything will remain the same. The only thing that's different is your starting point. Okay, so cosine starts from the maximum, which is going to be right here. So vertical displacement is going to be the same. Amplitude is going to be the same, which is 38. Period is still the same. It's 3, which means b again is 2 pi over 3. However, phase shift is not going to be 3 over 4 anymore. It's going to be twice as that. So you go 3 over 4 times 2, which is going to be 3 over 2. Or, okay, or cosine usually starts from the maximum. But you can see this case, cosine is starting at the minimum. So really what we can do is we can say that there is no phase shift, but now the graph is being flipped, which means A is now negative. Okay, so I'll show you 2 cosine functions. You can actually write 2 different ones. So you can write it as, let me just put it over here, cosine. You could have h of t is equal to, again, 38 cosine 2 pi over 3. And then t minus, in this case, is 3 over 2 plus 42. Okay, so that's one way of doing this. Or you can do it this way as well. Okay, so again, now we're assuming there's no phase shift, but now because we're starting from the minimum, that just means the graph has been flipped over the x-axis. So then, 38 became negative 38. And now you don't have phase shift anymore. Okay, so either or is going to be okay. Okay, either or is going to be okay. Okay, so yeah, so you can look at the graph and decide whether you want to have a phase shift or not. Okay, so that's your equation. Part B says, what is the height of the car 2 minutes after the wheel begins to rotate? So this one's easy. I'm going to use the sine function to solve this. It doesn't really matter which one you use, okay, because they all represent the same thing. I'm going to use the sine one here. So it's 2 pi over 3. 2 minutes after, so 2 minus 3/4. Remember, t is the time, plus 42. And now I need to put this into calculator. I don't have the answer here. So I would suggest you to do piece by piece. So I'm going to go 2 minus 3/4 first. So it's 2 minus 0.75 is 1.25. And then times 2 pi. And then divided by 3. And remember, you have to be in radian mode. So my calculator right now is in degree mode. So let me change that to radian mode first. Okay. And now we're going to take sine of that. So sine, answer. And then times that by 38. And then plus 42. You get exactly 61. 61, what is it, meters? It's an exact value because if you put this, if you think about this, okay, I'll show you. 2 pi over 3 times, this is 5 over 4. And you can see this is actually 5 pi over 6, which has a reference angle of pi over 6. So really, we think about this triangle right here. 1, 2, root 3. And we're looking at sine. So sine of pi over 6 is opposite over hypotenuse, which is 1/2. And because 5 pi over 6 is in second quadrant, so sine in second quadrant is positive. So this sine of that is going to be actually 1/2. So 38 times 1/2 is 19. 19 plus 42 is 61. So you can actually do this question without calculator. Okay, you just need to use your special triangle. So be careful. I might ask this question because I might give you 2 tests. Part 1, no calculator. Part 2, calculator. So you need to know how to do this one by hand as well. Okay, part C, it says, after how many minutes will you reach the height of 50 meters for the first time? Okay, so in this case, it gives us the height, and we're solving for t, so you simply put 50 into h of t. And again, I'm just going to use sine function this time. It doesn't matter which one, it doesn't matter which one you use, okay? Or maybe I'll use cosine this time. It doesn't really matter. Cosine 2 pi over 3 t minus 3/2 plus 42. Okay, to solve this, you need to first minus 42, so you get 8, right? And then divided by 38, you get cosine of 2 pi over 3 times t minus 3 over 2. Okay, now to solve this, you need to take the inverse cosine of that. I won't reduce it, it's okay, because I'm going to put it into calculator anyways. Pi over 3 times t minus 3/2. And now you need to get rid of this pi over 3. And to do that, you guys, you have to times 3 and divide it by pi. So it's going to be 3 times inverse cosine of 8 out of 38 divided by pi. This is going to equal to t minus 3 over 2. Finally, to solve for t, you simply add 3 over 2 to this side. Plus 3 over 2. All right, now we can put this into a calculator. So inverse cos of 8 out of 38 times by 3 divided by pi, and then plus 3 over 2 is 1.5. This is going to be 2.8 seconds, or 2.8 minutes. Okay, now let's compare this answer with the graph and see if it makes sense, okay? So 50 meters, we know the halfway point is 42. So 50 meters will be somewhere here. Now let's look at our answer. This is 2.8 minutes. And let's look at the graph. So the first time is going to be right here. Does that look like 2.8 minutes to you? Okay, hold on a second. 2.8, is that even right? Let me see. 8 out of inverse cos times 3 divided by pi plus 3/2, 2.8 minutes. Oh, that doesn't look right to me. 50, okay, 2.8 minutes. Let me see what happens here. Okay, so I found my mistake. This was 2 pi over 3 here. So I don't know why all of a sudden it became just pi over 3. So it should be 2 pi over 3. Therefore, it should be 3 times that and divided by 2 pi divided by 2 pi. Okay, so if you do this, you should get 2.1 minutes. So you see, I think it's really good that you compare it with the graph so you find your mistake. However, 2.1 minutes is not the answer. Okay, so again, let's look at this answer and compare to our graph. 2.1 minutes, so this is 3 minutes right here. And this is halfway point, so this is going to be 1.5 minutes, which is the 3 over 2, right? But so that means 2.1 is actually right here. It's somewhere here. The answer that we solved for is actually, the answer that we solved for is actually the one right here. But that's not the first time. The first time is right here. Okay, so again, we solve for this, and the reason why is because we use cosine, and cosine starts from the maximum. So we actually start from here, and if we use that equation, obviously, then that will be the answer that we got, because that will be the first one after the 3 over 2 over there. So this will be the first. That's the answer that we actually solved. But that's not the first time. The first time is actually this one right here. So how do we figure out that answer then instead? Well, because there's a good thing about this sine and cosine graph, it's symmetrical, okay? So this is 1.5 minutes, and we know at this time, this is 2.1 minutes, which means from here to here, it takes 0.6 minutes. So let me say it again. From the maximum to this point, it takes from 1.5 to 2.1, so it takes 0.6 minutes, which means from this point, if you backtrack, okay, so from this point, going back this way to this point, it also takes 0.6 minutes, which means this is going to be 1.5 minus 0.6. Okay, so our answer is actually going to be 1.5 minus 0.6, which is 0.9 minutes. That would be the final answer actually. Okay, so let me say it again. Because the distance or the time it takes to go from the maximum to 50 meters right here, it takes 0.6 minutes. It's the same thing because it's symmetrical. So if you backtrack, if you go this way, this from here 80 to 50, it's also going to take 0.6 minutes, which means 1.5 take away 0.6, and that's how you get the 0.9 minutes. Okay, so you should always do a quick sketch and then just see if it makes sense on the graph. And if it doesn't, you kind of need to analyze it a little bit. Okay. All right. I'll give you time to try this one here, and we'll go over the answer in a bit. Okay, good luck. I guess before you continue, let's make it the same for both. Okay, so there are two practice questions here. Let's say the first one, we are gonna find the sine function. Okay, and let's say the second one, we'll do the cosine function. Where is that a good idea to do it? Let me see. The tire has a. You know what? No, let's do cosine here first. And then let's do sine function here. Okay, so this one we use sine function. Okay, so then we will be consistent, and it'll be easier to compare the answers. Okay, good luck. All right, let's look at the answers here. Okay, so the first one, you should be able to draw this quick sketch right here. It goes from 15 centimeters to 35 centimeters. Okay, and it takes 20 seconds for one cycle. Okay, so you can see my 20 seconds. Here's my one period. Goes from 15 to 35 back to 15. So I can find the vertical displacement again. That's just the max plus min divided by 2. So I get 25. Amplitude simply max minus the center line, which is 10. So the period is as 20 seconds. So b, the value of b will be 2 pi over p. So 2 pi over 20. Notice I did not simplify it. I just left it as it is. It gives me more information actually, because if I see this, I know right away my period is 20 seconds. Because we're writing a cosine function, so I'm going to assume that we start from the center, or sorry, we start from minimum. In that case, phase shift will be 0, but that means that a would have to be less than 0. because we start from minimum, okay? So there's my function, h of t is negative 10. And notice it's not just positive 10, it's negative 10 because we start from minimum. Cosine of 2 pi over 20 times t, there's no phase shift, so b is 2 pi over 20 plus the vertical displacement of 25. Okay, part B, we simply plug in 26 into t, and you get 28.1. Hopefully that's what we got. Part C, you simply put 30 into h of t, and then you can solve accordingly. And again, if you just do it step by step, you should get 6.6 seconds. You should always compare this with the graph. We're looking for reaches 30 centimeters for the first time. So 30 is here, and this is right here. So that looks like 6.6 seconds. That looks fine to me. So I know that answer is no problem. Okay. Moving on to the next practice question here. It says a nail is caught in the tread of a rotating tire at point N in the following sketch. So here's N. We're writing a sine graph. So that's perfect because that's the center line, right? That's in the middle. So we know we're going to have a positive sine graph because it goes up first. So now we just need to find a vertical displacement. Well, again, vertical displacement is a center line, which is the average of the max and mean. Since the minimum is 0, the maximum is 50, the vertical displacement, which is halfway, is 25. Amplitude is max minus center line, so 50 minus 25 is 25. Period. So this is where it's tricky. It says it rotates at 10 revolutions per minute, which means one revolution is actually 6 seconds, right? 1 minute is 60 seconds. If it's 10 revolutions per 60 seconds, that means each revolution takes 6 seconds. So that's the period, okay? Period is 6 seconds, which means B is going to be 2 pi over 6. And because we're writing a sine graph, so phase shift will be 0 in this case. So h of t is going to equal to 25, that's A, so amplitude 25, sine of 2 pi over 6, that's B, times t, plus the vertical displacement of 25. Finally, part B, after how many seconds is the nail 10 centimeters above the ground for the first time? So again, I put 10 there, and then I solve for equation. You notice the answer is actually negative 0.61. Obviously, that cannot be true because, time cannot go backwards. So what it's saying is if you could actually go back in time, the graph is going to be like this, right? And it's going to be 20 meters or 20 centimeters above ground right here. Okay, and that it takes 0.61 seconds again. So that means from here to here it takes 0.61 seconds, which means the next time it gets to that point is going to be right here. Okay, so that means from here, so it's going to go to there, and the next time that it's going to reach that height, this is going to take 0.61 seconds. So now the question is then, how long does it take to go from here to here? Well, that's half of the cycle, right? Because that's half of the sine graph of one period. Therefore, because the period is 6 seconds, so from here to here, this is going to take 3 seconds, plus the 0.61 seconds right there. Again, this is 0.61 because this takes 0.61 seconds. And again, it's symmetrical, so this is also going to be 0.61. So your answer is actually going to be 3 plus 0.61, which is 3.61 seconds. Okay, notice how important it is to draw a quick sketch because it tells you if your answer makes sense or not, and then how you can adjust to get the right one that you wanted. Okay, last example that I need to show you today. It says the following data show the predicted tide heights every 2 hours starting at midnight for St. Andrews PEI on March 9th, 2011. So 00, obviously that's the 12 o'clock midnight. Okay, 00. 4.6, that's the height, 4.6 meters. And then at 2 o'clock in the morning, 6.5, and so on. Part A says graph the data and then write the equation of a sinusoidal function that models the data. Okay, so what we're going to do is we're going to sketch first. All right, so how many boxes? 1, 2, 3, 4, 5. Oh, we should have enough. Do I have 24? I don't know. Okay, fine, I'll do it like this. What's the biggest value? 6.5. So 1, 2, 3, 4, 5, 6. Okay, so I guess we'll just make one each. So that's 2, 4, 6, 8. And I'm going to say that's 2 o'clock, 4, 6, 8, 10, 12. Do I have enough? Oh, it doesn't look like I have enough. 14, 16, 18, 20. Not quite enough. Okay, well then I guess 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Okay, so now we can plot. Okay, so I'll give you some time to plot these points on the grid, okay? And we'll come back and finish the question. All right, so I plot the points, and I kind of like join them with dash curves, and it does look like a sine graph, okay, or cosine graph, sinusoidal function for sure. Notice how I circle these 3 points. This is my highest, and this is my second highest, so I'm assuming that would be like one period, right, from highest to the highest. This is my lowest, so I circle that one, so then I can figure out the amplitude and the center line. Okay, so again, we should find vertical displacement first. This is simply the maximum plus the minimum, because that's the center line, so take the average divided by 2. This is going to be 7.9 divided by 2, so 4.45, I think. 7.9 divided by 2, 3.95. Oh my goodness. Whew, 3.95. My mental math is getting worse and worse each year. Getting older and older. All right, amplitude. Amplitude is simply the maximum minus the center line. So I'm going to take 6.5 minus 3.95. So this should be 2.55. Okay. Yes, that's right. Okay, I know this time is right. Okay, the period. Again, period, you need to look at from maximum, that's 2 o'clock, to 6.1, that's 14 o'clock. So it takes 12 hours. So the period would be 12 hours, which kind of makes sense, right? Because in the day it's 24 hours, it has 2 tides. So period is 12. Therefore, the value of B is 2 pi over 12. And finally, the phase shift. We haven't figured out which graph we're going to use, hey? Why don't we use cosine graph? Sure, cosine graph start from the maximum, which is 2 hours to the right. So that'll be 2. Okay, so now we can write an equation, h of t. I will tell you which function you need to write, sine or cosine, on the test, okay, for sure. So it's easier for me to mark, for sure, because I don't need to do 2 answers. Okay, so h of t is going to be the amplitude, which is 2.55. Now, this time it's not going to be negative because we do start from the maximum. Cosine, 2 pi, the value of b is 2 pi over period, which is 12, times t minus the phase shift of 2 hours, plus the vertical displacement of 3.95. And there's our equation. That models the data. Okay. Part B says estimate the tide height at 17 o'clock, so 5 p.m. Give the answer to the nearest tenth of a meter. So all we need to do is put 17 into t, and that's it. Okay. 2 pi over 12, 17 minus 2, plus 3.95. Okay, notice we're working with 24-hour clock. Okay, so 17 minus 2 is 15, times 2 pi, divided by 12. I have a feeling that this is a special triangle again. We take the cosine of that. Well, that's 0. So times 2.55, that's 0, plus 3.95, that's right here, 3.95. So 17 hours is exactly where okay, so again, that's based on the model, right? But if you look at this, yeah, it could be, I suppose. Could be somewhere here. I think that's a pretty good estimation, 3.95 meters. Round to the nearest tenth, so I guess 4 meters then. Okay, so yeah, that's it. You can see, again, in real situations, a lot of times it does follow sinusoidal function, but it's not going to be exact points, right? So like this situation where we actually need to estimate, right? We kind of model it. It's not going to be exactly the sine graph. It's not going to be exactly this function, right? It's not going to follow this completely. But we can use this to model, to approximate, to estimate. Okay, that's the key. And if we do it enough times, it's going to be quite accurate, actually. Okay, because it kind of normalize it out. That's about stats. Anyways, all right. That's it for this lesson, and that's it actually for this unit. It's kind of hard, maybe. I know chapter 8 is it's quite challenging. Um, but you need to make sure you know how to solve trig equations because we're going to do more in unit 9, and we're actually going to deal with even more challenging equations. Okay, so good luck with your practice questions, and let me know if you need help. Okay, see ya.